Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, how does Azure Machine Learning supports distributed training? The answer should be, Azure Machine Learning supports distributed training through the following mechanisms. Multi-node cluster. Use Azure ML compute clusters with multiple nodes to distribute training workloads across several machines. Framework support supports distributed training for framework like TensorFlow, PyTorch and MPI through built-in integration and configuration options. Configuration. Define distributed training jobs using the MPI configuration, TensorFlow configuration or PyTorch configuration classes in the Azure ML SDK. Specify the number of nodes and processes per node for the training job. Orchestration. Use ML pipelines to orchestrate distributed training workflows including data preparation, model training and evaluation stages. Pipelines ensure that distributed training steps are executed in the coordinated and reproducible manner. Data access. Utilize shared data storage, example Azure Blob Storage, Azure Data Lake, accessible from all nodes to ensure consistent data access. Implement data sharding and partitioning strategies to distribute data across nodes effectively. Our next question is, what is Azure Cognitive Service and how it can be used in conjunction with Azure ML? Your answer should be, Azure Cognitive Service is the collection of pre-built APIs and services that enables developers to add AI capabilities and applications without extensive machine learning knowledge. These services can be used in conjunction with Azure ML in following ways. The first one is enhancing ML models. Use cognitive services APIs, example, text analytics, computer vision speech, to pre-process and enrich data before feeding it into custom ML models. Combine cognitive service with custom models to build more comprehensive AI solutions. Model integration. Integrate cognitive service directly into Azure ML pipelines for tasks like text analysis, sentiment analysis, image recognition, and more. Use the outputs from cognitive services as features in custom ML models. Hybrid solutions. Create hybrid solutions where cognitive services handle common tasks and Azure ML model address more specific or complex problems. For example, use the text analysis API to extract key phrase from document, then use the Azure ML model to classify documents based on extracted features. Data augmentation. Augment datasets using cognitive service to generate additional labels or features, improving the training data quality and model performance. Use service like Azure from Recognizer to extract structured data from documents and use it in training ML models. Seamless integration. Leverage the Azure ecosystem to integrate cognitive service and Azure ML with the Azure services. Example, Azure Functions, Logic Apps for end-to-end AI workflows. Use Azure Logic Apps to automate data flows between cognitive service and Azure ML, creating scalable and automated AI solutions. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, What is Azure Machine Learning and what are its key components? Your answer should be Azure Machine Learning is a cloud-based service provided by Microsoft Azure that enables data scientists and developers to build, train, and deploy machine learning models. Its primary components include Workspace, the central hub where all Azure ML resources are created and managed. Datasets, collections of data using the training and evaluation. Compute resources, various sources options like Azure ML Compute, Azure Kubernetes Service, AKS, and Azure Databricks. Experiment, tracks, runs, and manage machine learning experiment. Pipelines, automate and orchestrate the machine learning workflows. Models, registered and version trained models. Endpoints, deployed models in real time for batch scoring. Environments, defined runtime environments including dependencies for consistency across different stages in model development. Our next question is, how does Azure ML support the entire machine learning life cycle? Your answer should be Azure ML supports the entire machine learning life cycle through the following stages. Data ingestion and preparation. Integrates with data storage solutions, Azure Blob Storage, Azure Data Lake, and provides tools for data pre-processing and transformation. Model training offers scalable compute resources and supports various frameworks. Example, TensorFlow, PyTorch, or training models. Model evaluation provides tools to evaluate and compare model performance using metrics and visualization. Model registration allows for versioning and registering models in a central repository. Model deployment facilitates deploying models to different environments, example AKS, ACI, and generating REST endpoints for real-time interface. Monitoring and management enables monitoring and deployed models for performance and data drift, ensuring models stay accurate and reliable over time. Automation and orchestration use ML pipelines to automate repetitive tasks and orchestrate complex workflows. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, what is hyperdrive in Azure Machine Learning and how do you use it? Your answer should be hyperdrive in Azure ML's tools for hyperparameter tuning. It allows you to find the best set of hyperparameters for your machine learning model using different search strategies. Steps to use hyperdrive. Step 1. Define the search space. Specify the range of hyperparameters to tune. Step 2. Configure the experiment. Set up the experiment including the primary metric to optimize and compute resources. Step 3. Select the search strategy. Choose from strategies like random search, grid search or Bayesian optimization. Step 4. Run the experiment. Execute the hyperdrive experiment to evaluate different hyperparameter combinations. Step 5. Analyze results. Review the results to find the best performing hyperparameters. Our next question is, can you use Azure Data Factory in a machine learning workflow? Your answer should be, Azure Data Factory ADF can be used to orchestrate and automate data workflow in machine pipeline. Your answer should be, the options for it is data ingestion. Collect and integrate the data from various sources into Azure storage. Data transformation. Clean and pre-process data using ATF data flows capabilities. Data movement. Move data between different storage and compute environments. Integration with Azure ML. Use ATF to trigger Azure ML pipelines, ensuring data is ready for training and schooling. Scheduling. Automate and scheduling data pipelines to ensure continuous and data processing and model retraining. Our next question is, what Our next question is, what is the importance of model explainability and how it is achieved in Azure Machine Learning? Your answer should be, model explainability is crucial for understanding trust and regulatory compliance. It helps stakeholders to understand how a model makes decisions and ensure transparency. In Azure ML, explainability is achieved through Interpretability Toolkit. Provides tools like sharp, shapely additive explanation and line local interpretable model agnostic explanation to explain model prediction. Feature importance identifies which feature most influence the model prediction. Fairness assessment evaluates whether the model treats different demographic groups fairly. These tools help in interpreting and understanding model behavior, enhancing trust, and facilitating decision making. Our next question is, explain the concept of AutoML in Azure Machine Learning. Your answer should be, AutoML in Azure ML automates the process of applying machine learning to real-world problems. It helps in algorithmic selection, automatically selects the best algorithm for the given task. Hyperparameter tuning, optimizes hyperparameters to improve model performance. Feature engineering, applies techniques to enhance model accuracy, model evaluation, provides performance metrics and model explanations. Ease of use, simplifies the machine learning workflow, making it accessible to users with varying level of expertise. Our next question is, what are the best practices for deploying machine learning models in Azure? Your answer should be, model versioning. Keep track of different model versions for better management and roll back if needed. Scalability. Use scalable computer targets like AKS or handling varying loads. Monitoring. Implement monitoring with application insights and Azure Monitor to track model performance and detect issues. Security. Use RBAC, network isolation, and data encryption to secure your models and data. CI/CD pipelines. Set up continuous integration and continuous deployment process to automate and streamline the deployment process. Performance testing. Perform load testing and to ensure the deployed models can be handled at expected traffic. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, what are the different ways to deploy models in Azure Machine Learning? Your answer should be, Azure Machine Learning supports several deployment methods. First one is Azure Kubernetes Service, AKS. for real-time, scalable deployments that need high availability and low latency. Azure Container Instances (ACI) for development, testing, low-scale production deployments, quick and easy to set up. Azure Functions for serverless deployment, ideal for event-driven applications. Azure IoT Edge for deploying models on IoT devices, enabling edge computing. Batch inference for processing large datasets at once using Azure Batch or Databricks. Our next question is, how do you monitor performance for the deployed models in Azure ML? Your answer should be to monitor deployed models in Azure ML. Application Insights integrate to collect telemetry data such as request rates, response times, and failure rates. Azure Monitor track metrics and logs, set up alert anomalies. Logging use built-in logging, capture models inputs, outputs, and errors. Mirror metrics track custom metrics like accuracy, precision, recall using the Azure ML SDK. Dashboards create dashboards to visualize the performance metrics and logs. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated questions and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe to our channel. You can download the complete list of valid, tried, tested, current and updated question and answers from the playlist link provided in the description. Do share please. The question is, how do you secure machine learning environments in Azure? Your answer should be, securing machine learning environments in Azure involves several best practices. Role-based access control (RBAC) define roles and permissions to control who can access resources. Virtual networks isolate compute resources and limit access to them. Data encryption use encryption of data at rest and in transit. Azure Key Vault manage secrets, keys and certificates securely. Auditing and monitoring enable logging and monitoring to detect and respond to security incidents. Implementing these measures ensure that machine learning workflows are protected against unauthorized access and data breaches. Our next question is, what is the difference between Azure Blob Storage and Azure Data Lake Storage? Your answer should be, Azure Blob Storage optimized for storing massive amounts of unconstructed data such as text or binary data. It is ideal for serving images and documents directly to the browser, storing files for distributed access and streaming videos and audio. Azure Data Lake Storage built on top of Azure Blob Storage, it is optimized for big data analytics. It includes capabilities such as hierarchical namespace, fine-grained security, and support for Hadoop computable analytics engines like Spark and Hadoop. Our next question is, how do you use Azure ML for model training and deployment? Your answer should be, model training. Prepare data. Store and pre-processes data using Azure Blob Storage or Azure Data Lake. Define experiment. Use Azure ML SDK or Designer to set up the training experiment. Compute targets. Select compute resources, example local, Azure ML Compute, Databricks. Train models. Execute the experiment tuning hyperparameters as needed. Register model. Save and register the trained models in the Azure ML workspace. Now, model deployment. Interference configuration. Create an inference script and specify dependencies. Deploy model. Use Azure ML to deploy the model to Azure Kubernetes Services (AKS), Azure Container Instances (ACI), and other compute targets. Create endpoints. Set up REST endpoints to enable real-time predictions. Monitor. Use application insights to Azure Monitor for logging and performance tracking. Our next question is, explain the concept of data drift in machine learning and how you handle it in Azure ML. Your answer should be, data drift occurs when the statistical properties of input data change over time, leading to model performance degradation. Handling data drift in Azure ML. Monitoring. Use Azure ML's data drift detection capabilities to monitor data changes. Alerts. Set up alerts to notify when significant data drift is detected. Retaining pipelines. Automate the retaining of models using Azure ML pipelines. Version control. Track model versions to manage updates and roll back if necessary. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, what are the different types of computer targets available in Azure Machine Learning? Your answer should be, local compute. Run experiments on your local machine for development and testing. Azure ML Compute. Manage clusters for virtual machines that scale automatically for training jobs. Azure Kubernetes Services (AKS) for deploying and managing containerized applications at scale. Azure Batch for large-scale parallel and batch compute jobs. Azure Databricks for big data processing and advanced analytics. Virtual machines (VMS), customizable VMS for specialized workloads. Our next question is, how do you ensure the security of data and models in Azure Machine Learning? Your answer should be, role-based access control (RBAC). Define roles and assign permissions to control access to resources. Network isolation. Use virtual networks to isolate compute resources and restrict access. Data encryption. Implement encryption of data at rest and in transit. Azure Key Vault. Securely manage secrets, keys and certificates. Compliance. Adhere to regulatory compliance requirements, example, GDPR and HIPAA. Monitoring and logging. Enabling Azure Monitor and application insights for auditing and tracking. Our next question is, what is the role of Azure Machine Learning SDK? Your answer should be, the Azure Machine Learning SDK is a Python-based toolkit that provides experimentation, create, manage and run experiments, model management, register, version and deploy models, data preparation, load and transform data, compute management, set up and manage compute targets, pipelines, define the run machine learning pipelines, monitoring, track experiment metrics and monitor deployed models. The SDK allows data scientists and developers to programmatically interact with Azure ML services for end-to-end machine learning workflows. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone. Welcome back to our channel. Today, we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe to our channel. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, what are the best practices for maintaining and managing machine learning models in production in Azure? Your answer should be versioning. Keep track on model versions for better management and rollback if needed. Monitoring. Continuous monitor model performance and data drift using Azure Monitor and Application Insights. Automation. Use CI/CD pipelines to automate model updates and deployments. Scalability. Ensure deployment environment, example AKS, can scale with demand. Security. Implement RBAC, encrypt data at rest and in transit, and use Azure Key Vault for managing secrets. Documentation. Maintain comprehensive documentation of models including assumptions, dependencies, and performance metrics. Retraining. Schedule regular training of models to maintain performance over time. Our next question is, how do you optimize the cost of running machine learning workloads in Azure? Your answer should be Spot VMS. Use Azure Spot VMS for cost-effective compute resources suitable for fault-tolerant and flexible workloads. Scaling. Utilize auto-scaling capabilities to dynamically adjust compute resources based on workload demand. Cost management tool. Use cost management and billing tools to monitor and optimize spending. Resource allocation. Right-size compute resources, example VM types, to match workload requirements. Job scheduling. Schedule compute-intensive jobs during off-peak hours when rates might be lower. Optimize data storage. Choose appropriate data storage solutions, example, blob storage, Azure Data Lake, and manage data lifecycle to control costs. Our next question is, what is AutoML in Azure ML and how does it simplify the machine learning workflow? Your answer should be AutoML machine learning. Automated machine learning in Azure ML automates the end-to-end process of applying machine learning to real-world problems. It simplifies the workflow by algorithm selection, automatically selects the best algorithm for the given task. Hyperparameter tuning optimizes hyperparameters to improve model performance. Feature engineering automatically applies techniques to enhance model accuracy. Model evaluation provides comprehensive and evaluation metrics and model explanations. Deployment facilitates easy deployment of the best model. This reduces the need of extensive ML expertise and accelerates the development processes. Our next question is, how do you use Azure Databricks in conjunction with Azure Machine Learning? Your answer should be Azure Databricks integrates with Azure ML to enhance data processing and ML workflows. Data preparation. Use Databricks for large-scale data cleaning, transformation, and aggregation. Model training. Train models using Spark MLlib or custom frameworks in Databricks notebooks. Integration. Link Databricks with Azure ML to seamlessly transition data and models within services. Experimentation. Track and manage experiment in Azure ML, even those run in Databricks. Deployment. Register model trains in Databricks with Azure ML and deploy them using Azure ML's deployment infrastructure. Scalability. Leverage Databricks for distributed computing and large-scale model training. Our next question is, what is the role of Azure Data Factory in an ML pipeline? Your answer should be, Azure Data Factory ADF orchestrates and automates data workflows within an ML pipeline. Data ingestion. Collect data from various sources, example, on-premise cloud databases, and move it to Azure storage. Data transformation. Clean and pre-process data using ADF data flow capabilities. Data movement. Transfer data between different storage solution and compute environments. Integration. Trigger Azure ML pipelines as part of the ADF workflows to ensure data is ready for training and scoring. Scheduling. Automate a scheduled data workflows to ensure continuous data processing and timely model retaining. ADF ensures that data is consistently prepared and available for machine learning processes. If you find this content helpful, please like, comment and subscribe. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone. Welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe to our channel. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, what is the difference between real-time inference and batch inference? Your answer should be, real-time inference. Models serve predictions in real time, typically via REST APIs, suitable for application requiring immediate responses like chatbots and recommendation systems. Batch inference. Predictions are made on large batches of data at scheduled intervals, suitable for applications like periodic data processing, storing large data sets, or generating reports. Our next question is, how do you handle missing data in your dataset when using Azure Machine Learning? Your answer should be, handling missing data involves imputation. Fill the missing values using mean, median, mode or a specific value. Deletion. Remove rows and columns with missing values if they are not significant. Model-based methods. Use algorithms that handle missing data internally. Feature engineering. Create new features indicating the presence of missing values. Azure ML Designer. Use the built-in models for data cleaning and in-processing. Our next question is, what are Azure Learning datasets and how they are used? The answer should be, Azure Machine Learning datasets are the way to manage and version data used in machine learning experiments. They are data management, simplified data access and sharing across experiments. Versioning, track challenges and datasets over time. Integration, easily integrate with Azure ML pipelines and experiments. Security, access controls and compliance with Azure security standards. Types, tabular disasters for structured data and are disasters for unstructured data. Our next question is, how does Azure Machine Learning ensure reproducibility of experiments? Your answer should be, Azure ML ensures reproducibility through experiment tracking, automatically logs parameters, metrics, outputs, and logs for each run. Pipeline versioning, Keep tracks of different versions of machine learning pipelines. Environment management. Use Docker containers and Conda environments to manage dependencies. Data versioning. Tracks versions of datasets used in experiments. Code repositories. Integrate with Git to track changes in experiment code. Our next question is, explain how would you set up machine learning pipeline in Azure ML? Your answer should be, to set up machine learning pipeline in Azure ML, define steps. Break down the workflow into steps like data preparation, training, evaluation, and deployment. Create pipeline. Use the Azure ML SDK or designer to create a pipeline by chaining these steps. Configure compute. Assign compute targets to each step, example, local ML compute. Submit pipeline. Submit the pipeline for execution, specifying input datasets and parameters. Monitoring and iterate. Monitoring the pipeline run, analyze results, and iterate as needed. If you find this content helpful, please like, comment, and subscribe to our channel. Our next question is, what is the purpose of using Azure Key Vault in Azure Machine Learning? Your answer should be, Azure Key Vault is used in Azure Machine Learning to securely manage secrets, keys, and certificates. It helps to secure credentials, store and manage access keys, database, connection strings, and API keys. Environmental variables. Use secrets stored in Key Vault as environment variables in ML experiments and deployments. Encryption. Manage encryption keys used for data protection. Access control. Implement fine-grained access control and audit logging for secret management. Integration. Easily integrate with Azure ML to enhance the security of machine learning workflows. Our next question is, describe how you can use Azure ML to work with big data. Your answer should be, to work with the big data in Azure ML, data storage. Use Azure Blob Storage or Secure Data Lake Storage to store large data sets. Data processing. Use Azure Databricks or HD Insights for scalable data processing and transformation. Integration. Use Azure Data Factory to orchestrate data movement and transformation workflows. Training at scale. Use distributed training with Azure ML Compute or Databricks. Batch scoring. Perform batch inference using Azure Batch or Databricks to handle large volumes of data. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, current, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone. Welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment, and subscribe. You can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Do share, please. The question is, describe the use of Azure Databricks in the context of Azure Machine Learning. Your answer should be, Azure Databricks integrates with Azure Machine Learning to enhance big data processing and machine learning workflows. Use cases include data preparation. Perform large-scale data pre-processing and transformation using Spark in Azure Databricks. Feature engineering. Implement complex feature engineering tasks in a distributed environment. Model training. Train machine learning models using MLlib or custom code on Databricks. Integration. Use Azure ML SKD to submit Databricks jobs and manage experiments directly from Azure ML. Scalability. Leverage Databricks auto-scaling capabilities for efficient resource utilization during training and data processing. Our next question is, what are the advantages of using Azure Kubernetes Services AKS for deploying machine learning models? Your answer should be, advantages of using Azure Kubernetes Service AKS for deploying machine learning models includes scalability, easily scale deployments ups or down based on demand, high availability, ensure high availability and reliability of deployed models through Kubernetes orchestration capabilities, load balancing, distribute inference requests evenly across multiple instances to optimize performance. Integration. Seamlessly integrate with other Azure services like Azure ML, Azure Monitor, and Azure DevOps. Security. Use Kubernetes built-in security features, example, RBAC network policies to secure deployments. Flexibility. Supports for deploying various types of models and integrating with different CI/CD pipelines. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, what steps are involved in creating a model deployment pipeline in Azure ML? Your answer should be, creating a model deployment pipeline in Azure ML involves: Step 1. Define pipeline steps. Use the Azure ML SDK to define steps for data pre-processing, model training, evaluation, and deployment. Create compute targets. Set up compute resources needed for each step, such as training on Azure ML Compute and deploying on AKS. Step 3. Build and pipeline. Change the defined steps into the pipeline using pipeline class in Azure ML SDK. Specify dependencies in execution order. Step 4. Submit the pipeline. Submit the pipeline for execution using the pipeline run object. Monitor the pipeline run for completion and errors. Step 5. Deploy the model. Use the deploy step to deploy the trained model to the specified compute target. Register the deployment as an endpoint for real-time interference. Our next question is, how do you ensure that your machine learning models are compliant with regulations like GDPR using Azure ML? Your answer should be, ensuring compliance with regulations like GDPR using Azure ML involves data privacy. Implement data anonymization and pseudonymization techniques to protect personal data. Data management. Use Azure Data Lake and Azure Blob Storage to securely store and manage data with access controls. Access controls. Implement role-based access control (RBAC) to restrict access to sensitive data and models. Audit trails. Maintain detailed logs of data access and model usage to provide audit trails. Data residency. Ensure data is stored and processed in compliant geographic locations. Encryption. Encrypt data at rest and in transit using Azure encryption services. Model interpretability. Use tools for model explainability to ensure decisions made by models are transparent and interpretable. Consent management. Implement mechanism for obtaining and managing user consent for data processing. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested, current and updated question and answers from the playlist link provided in the description. Do share please. The question is, how do you use Azure Databricks with Azure Machine Learning? Your answer should be, Azure Databricks can be integrated with Azure Machine Learning for large-scale data processing and advanced analytics. Steps to use Azure Databricks with Azure ML are: Step 1. Link Databricks Workspace. Connect your Azure Databricks Workspace to Azure ML. Step 2. Data Preparation. Use Databricks for ETL, extract, transform, and load operations and data wrangling. Training models. Train models using Spark ML Lib or custom ML frameworks. Example, TensorFlow, PyTorch in Databricks. Register models. Save and register trained models in Azure ML. Deploy models. Deploy models using Azure ML's deployment capabilities, leveraging Databricks as a compute target if necessary. Our next question is, what is the role of hyperparameters tuning in Azure Machine Learning? Your answer should be, hyperparameter tuning in Azure Machine Learning involves optimizing the parameters of machine learning models to improve their performance. Azure ML provides Hyperdrive, a service for conducting hyperparameter sweeps using different search strategies. Example, random, grid, Bayesian optimization. Parameter sampling. Define parameter spaces for tuning. Early termination policies. Stop poorly performing runs to save resources. Hyperdrive automates and accelerates the process of finding the best hyperparameters, ensuring optimal model performance. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, how do you handle data drift and model training in Azure ML? Your answer should be, data drift occurs when statistical properties of the input data change over time, potentially deregarding model performance. To handle data drift and model retention in Azure ML. Monitoring. Use Azure Monitor and Applications Insights to track model performance and detect data drift. Scheduled retraining. Set up automated pipelines for periodically retains models of new data. Trigger-based retraining. Retain models based on specific triggers such as significant changes in data patterns. Model versioning. Keep track of different model versions to compare and manage updates. Regularly monitoring and updating models helps to maintain their accuracy and relevance. Our next question is, what is the role of Azure Data Factory in machine learning workflow? Your answer should be, Azure Data Factory ADF is a data integration service that allows you to create data-driven workflows for orchestrating data movement and transformation. In a machine learning workflow, ADF can ingest data, collect data from various sources, example, databases, APIs files, and move it to Azure storage. Transform data. Perform data cleaning, transformation, and enrichment using ADF's data flow capabilities. Scheduled workflows. Automate and schedule data workflows to ensure data is ready for machine learning process. Integrates with Azure ML. Use ADF to trigger Azure ML pipelines and manage end-to-end machine learning workflows. ADF ensures that data is consistently prepared and available for training and deploying machine learning models. Our next question is, what is the difference between batch inference and real-time inference in Azure ML? Your answer should be batch inference. Processing large volumes of data at once, typically for tasks that do not require immediate results. Batch inference is suitable for offline predictions and can be run on a schedule using compute resources like Azure Databricks or Azure Batch. Real-time inference, providing immediate predictions for individual data points as they arrive. Real-time inference requires deploying models as web services using Azure Kubernetes Services (AKS) or Azure Container Instances (ACI) to handle real-time traffic. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone. Welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. Our question is, what are some best practices for feature engineering in Azure ML? Your answer should be understand data. Perform explanatory data analysis to understand the data distribution and relationships. Data cleaning. Handle missing values, outliers and duplicates. Feature selection. Use statistical methods or model-based approaches to select relevant features. Transformation. Apply transformation, example, normalization, encoding categorical values, and make data suitable for modeling. Automated feature engineering. Use toolkits like Azure ML, AutoML, which can automatically generate features. Pipeline integration. Incorporate features engineering steps into Azure ML pipelines and reproducibility. Our next question is, how do you use Azure Cognitive Service with Azure ML? Your answer should be, Azure Cognitive Service can be integrated with Azure ML to enhance machine learning models with pre-built AI capabilities. Steps include Step 1. API integration. Call Cognitive Services APIs, example, computer vision, text analytics from within Azure ML experiments or pipelines. Data enrichment. Use Cognitive Services to pre-process and enrich data. Example, extracting text for images, sentiment analysis, and text data. Custom models. Combine pre-built models from Cognitive Service with custom machine learning models developed in Azure ML. Deployment. Deploy integrated solutions as web services using Azure ML's deployment capabilities. Our next question is, how could you explain the concept of machine learning model deployment in Azure? The answer should be, model deployment in Azure involves making your trained machine learning model available for use in a production environment. The key steps are, register the model, save the trained model in Azure ML Workspace. Inference, configuration, define how the model will be used for predictions including the necessary environment and dependencies. Step 3. Deploy the model. Deploy the model to the compute targets like Azure Kubernetes Service AKS and Azure Container Instances ACI, creating an endpoint for real-time or batch inference. Test and monitor. Test the deployed model to ensure it works as the accepted and monitor its performance using the tools like Azure Monitor and Application Insights. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, what are the difference between Azure Machine Learning Compute and Azure Databricks? Your answer should be Azure Machine Learning Compute managed clusters of virtual machines that scale automatically. It is primarily used for training machines learning models. Pros: easy to set and manage, integrated with Azure ML for experimentation and deployment. Cons: less suited for large-scale data processing. Azure Databricks, an Apache Spark based on analytics platform optimized for big data processing, machine learning, and data engineering. Pros: excellent in big data analytics, support various data science and machine learning tasks, integrates well with other Azure services. Cons: more complex to manage, might be overkill or simple machine learning tasks. Our next question is, how do you handle imbalanced data sets in Azure Monitor Learning? Your answer should be, handling imbalanced data sets involves several techniques. Resampling, oversampling the minority class or undersampling the majority class. Synthetic data generation, using techniques like SMOTE, synthetic minority oversampling techniques, to create synthetic samples for the minority class. Algorithmic approaches, using the algorithms that are robust to class imbalance, example, tree-based methods, or modifying the algorithms to the account for class weights. Evaluation metrics, using appropriate evaluation metrics like precision recall curves, F1 score, or AUC ROC instead of accuracy. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, what are the key components of Azure Machine Learning Service? Your answer should be, Azure Machine Learning Service includes several key components. Workspaces, centralized spaces to manage your machine learning resources. Datasets, used to manage data for training and validation. Compute targets, including virtual machines and Azure machine learning compute clusters for running experiments. Models, storing and versioning trained models. Pipelines, automating workflows from data preparation to model deployment. Endpoints, for deploying and serving models as web services. Our next question is, how do you manage and version your machine learning models in Azure ML? Your answer should be, In Azure ML, models are managed and versioned through Azure ML Workspace. You can register model in a workspace to keep track of different versions. Use the Azure ML SDK or CLI to programmatically manage models. Attach metadata, tags, and descriptions to models for better organization. Track the model lineage to understand the origin and transformations that the model has undergone. Our next question is, explain the difference between Azure ML Designer and Azure ML SDK. Your answer should be Azure ML Designer, a drag and drop interface that allows you to create machine learning models visually. It is suitable for users who prefer a no-code or low-code approach. Azure ML SDK, a Python-based SDK that offers greater flexibility and control for creating, managing, and deploying machine learning models programmatically. It is suited for data scientists and developers who are comfortable with coding. If you find this content helpful, please like, comment, and subscribe to our channel. Our next question is, how would you deploy a machine learning model in Azure? Your answer should be, to deploy a machine learning model in Azure, you can follow these steps. Step 1. Register the model. Register your model in the Azure ML workspace. Step 2. Create an interference configuration. Define how the model should be loaded and scored using a inference script and necessary dependencies. Step 3. Set up the deployment configuration. Configure the deployment specifying the compute resources, example, Azure Kubernetes Service, Azure Container Instances. Step 4. Deploy the model. Use the deploy method from the Azure ML SDK to deploy the model to the chosen compute target. Step 5. Test the endpoint. Once deployed, test the endpoint by sending HTTP request with sample data to ensure it is working as expected. Our next question is, what are the different compute targets you can use in Azure machines? Learning. Your answer should be, Azure machine learning supports various compute targets. Local compute. Running experiments on your local machine. Azure Machine Learning Compute. Manage clusters of VMS that can scale automatically. Azure Kubernetes Service AKS for large-scale high-availability deployments. Azure Databricks for big data processing and large-scale machine learning. Virtual machines, dedicated VMS for custom configurations. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. Our question is, how do you handle model training in Azure ML? Your answer should be, handling model training in Azure ML involves automation. Use ML pipelines to automate the retraining process. Scheduled retraining. Set up schedules to periodically retrain models using updated data. Data drift monitoring. Monitor for data drift and trigger retraining when significant changes in data distribution is detected. Model management. Keep track on model versions and performance metrics to ensure The best model is always in production. Continuous integration or continuous deployment (CI/CD). Implement CI/CD practices to automatically retrain, test, and deploy models. Our next question is, what is the role of Azure Data Lake in machine learning project? Your answer should be, Azure Data Lake plays a crucial role in machine learning projects by providing scalable storage, stores large volumes of structured and unstructured data. Data integration integrates with various data sources for seamless data ingestion. Data preprocessing supports data transformation and cleaning using Azure Data Factory and Databricks. Hierarchical namespace organizes data into directories and subdirectories for efficient access and management. Security ensures data security with access control and encryption. Analytics facilitates big data analytics using tools like Azure Databricks and HD Insights. Our next question is, explain the architecture of machine learning and its key components. Your answer should be, Azure Machine Learning Architects consists of several key components that work together to facilitate end-to-end machine learning life cycle. Workspace, a central place to manage all Azure ML assets including experiments, data, models, deployments, and compute resources. Datasets, managed and versioned collections of data used in experiments. Azure ML supports both tabular and file datasets. Compute targets, the compute resources used in training and inference such as local compute, Azure ML Compute, Azure Kubernetes Service AKS, and Azure Databricks. Experiment, a way to organize and track runs where each run represents a single execution of a training script. Pipelines, workflows that automates and orchestrate the different stages of the machine learning process from data preparation to model deployment. Models, registered and version models for training runs stored in the workspaces. Endpoints, deployed models available at REST endpoints for real-time or batch predictions. Environments, definitions of the runtime environment, example, Python package, Docker images for consistent and reproducible runs. Monitor and management, tools for tracking experiment metrics, managing model life cycle, and monitoring deployed endpoints. If you find this content helpful, please like, comment, and subscribe to our channel. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment, and subscribe to our channel. You can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Do share please. The question is, what is AutoML in Azure ML and how does it help data scientists? Your answer should be, AutoML in Azure ML automates the process of applying machine learning to real-world problems. It helps data scientists by automatically selecting the best algorithms and tuning hyperparameters, performing feature engineering and model selection, providing model explainability and performance metrics, reducing the time and effort required to build high-quality models. Our next question is, describe how you can monitor and maintain deployed models in Azure. Your answer should be, to monitor and maintain deployed models in Azure, Application Insights integrates with Application Insights to monitor the performance and usage of deployed models. Azure Monitor. Use Azure Monitor to track logs, metrics, and alerts. Model drift detection. Set up pipelines to regularly retain models to address data drift. Logging and diagnostics. Collects logs and diagnostics to identify issues and maintain model health. Azure ML Studio. Use Azure ML Studio to manage and monitor experiments and models through a web interface. Our next question is, how do you handle data preparation and feature engineering in Azure ML? Your answer should be, data preparation and feature engineering in Azure ML can be handled using Azure ML Designer. Drag and drop modules for data transformation, cleaning, and feature extraction. Azure ML SDK. Use Python scripts to pre-process data, apply transformation, and create features. Azure Databricks. For large-scale data processing and advanced feature engineering. Data wrangling data flows. Visual tools for data preparation and transformation. If you find this content helpful, please like, comment, and subscribe to our channel. Our next question is, what are Azure machine learning pipelines and how they are used? Your answer should be, Azure machine learning pipelines are the way to orchestrate machine learning workflows. They help in automating, managing, and optimizing machine learning processes from data preparation, model training to deployment. Key component includes steps, each stage in a pipeline, example, data preparation, training, evaluation, data sets, input data for each step, compute targets, where the steps are executed, example, local, Azure ML, compute, scheduling, automating pipelines runs based on triggers and schedules. Use pipelines ensures reproducibility, scalability, and efficient use of resources. Our next question is, can you explain the concept of model explainability and Azure machine learning? Your answer should be, model explainability in Azure machine learning refers to the ability to understand and interpret the predictions made by machine learning models. Azure provides tools like Interpretability Toolkit, tools to examine model predictions including sharp, shapely adaptive explanations, and line, local interpretable model agnostic explanations. Feature importance, identifying which features most influence the model prediction. Fairness indicators, assessing whether the model treats all demographic groups fairly. These tools help in building trust and ensuring models comply with the ethical standard and regulations. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. Our next question is, explain how AutoML works in Azure ML. Your answer should be, AutoML, automated machine learning in Azure ML automates the process of model development. Here is how it works. Data preparation. AutoML takes raw data and applies necessary pre-processing steps such as normalization, imputation, and feature engineering. Algorithm selection. It explores a wide range of algorithms to identify the best performing ones for the given task. Hyperparameter tuning. AutoML automatically tunes hyperparameters to optimize model performance. Model evaluation. It evaluates multiple models using various metrics to determine the best model. Model interpretability provides explanation and best feature importance to help and understand the model behavior. Deployment facilitates easy deployment of the best model to production environments. Our next question is, how do you set up a compute instance and use it in Azure ML? Your answer should be, setting up the compute instance in Azure ML involves Step 1. Create a compute instance. Go to the Azure ML workspace in the Azure portal. Navigate to the Compute section and select Compute Instances. Click New and configure the instance. Select VM size, name, etc. Click Create. Using the compute instance, this is Step 2. Once the compute instance is running, you can use it for development and experimentation. Act Jupyter Notebooks or Jupyter Lab directly from the Azure ML workspace to run experimentally interactively. Attach the compute instance to experiments and pipelines for consistent runtime environments. If you find this content helpful, please like, comment and subscribe to our channel. Our next question is, what is machine learning pipeline in Azure ML and what are its benefits? Your answer should be, a machine learning pipeline in Azure ML is an automated workflow that chains together different stages of the machine learning process. Benefits includes reproducibility, ensures the same steps are executed consistently across runs. Automation, reduce manual intervention by automating data pre-processing, model training, evaluation and deployment. Scalability, allows for parallel execution of tasks, speeding up the workflow. Modularity, facilitates the reuse of pipeline components in different workflows. Tracking and monitoring, provides the tools to track the performance of each pipeline step and monitor overall workflow progress. Our next question is, how do you monitor deployed models in Azure ML? Your answer should be, monitoring deploy models in Azure ML involves application insights. Integrate with application insights to track metrics such as request rates, response times, and failure rates. Azure Monitor. Use Azure Monitor to set up alerts and dashboards for real-time monitoring of model performance. Data drift detection. Use built-in and data drift detection capabilities to monitor changes in input data and retrain models if significant drift is detected. Logging. Implement custom logging in scoring scripts to capture detailed logs of interference requests and responses. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe to our channel. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, can you explain the process of setting up an Azure machine learning workspace? Your answer should be, set up Azure machine learning workspace involves the following steps. Step 1. Create a workspace. Go to the Azure portal and click on Create a Resource. Search for machine learning and select machine learning workspace. Fill in the necessary details, example, workspace name, subscription, resource group, location. Review and create workspace. Step 2. Configure workspace. Once created, configure the workspace by setting up linked resources like Azure Storage, Azure Container Registry, and compute targets. Access the workspace. Use the Azure ML Studio web interface or the Azure ML SDK to access and manage the workspace. Manage resources. Use the workspaces to manage datasets, experiments, models, and deployments. Our next question is, describe the use of Azure Databricks in machine learning. Your answer should be, Azure Databricks is the analytics performance optimized for Azure cloud services and is being used for big data processing and machine learning. Data processing. Use Spark-based data processing for ETL tasks handling large-scale datasets efficiently. Collaborative notebooks. Develop and execute ML code in interactive notebooks that support Python, Scala, R, and SQL. Integration with Azure ML. Seamlessly integrate with Azure ML for model training and deployment. Scalable compute. Leverage auto-scaling clusters for distributed machine learning tasks. Machine learning libraries. Utilize built-in libraries like MLlib and integrate with external ML frameworks. Example, TensorFlow, PyTorch. Point 6. End-to-end workflow. Support the entire ML lifecycle from data ingestion and pre-processing of model training, evaluation, and deployment. If you find this content helpful, please like, comment, and subscribe to our channel. Our next question is, how do you manage and version datasets in Azure Machine Learning? Your answer should be, managing and versioning datasets in Azure Machine Learning involves data registration. Register datasets in the Azure ML workspace providing metadata descriptions. Versioning. Tracks changes in creating new versions of datasets whenever data is updated or modified. Data classes. Use dataset class in Azure ML SDK to define and work with datasets including tabular dataset for structured data and file datasets for unstructured data. Labeling. Apply labels to datasets for easy identification and categorization. Data lineage. Maintain data lineage to track the origin and transformation of data over time. Access control. Control access to datasets through RBAC, ensuring only authorized users can view or modify them. Our next question is, what are some key features for Azure Machine Learning, Automated Machine Learning, AutoML? Your answer should be, key features of Azure Machine Learning, AutoML include algorithm selection. Automatically selects the best algorithm for the given task. Hyperparameter tuning. Optimizes hyperparameter to improve model performance. Feature engineering. Apply the techniques to enhance model accuracy and robustness. Model evaluation. Provides comprehensive evaluation metrics to compare model performance. Model interpretability. Offers tools to interpret and explain model prediction. Deployment. Facilitates easy deployment of the best performing models. Time series forecasting. Support time series forecasting including handling seasonality and trend detection. Integration integrates with other Azure services for data preparation, monitoring, and management. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, current, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone, welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe to our channel. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, how do you perform hyperparameter tuning in Azure ML? Your answer should be performance hyperparameter tuning in Azure ML using Hyperdrive. Define search space. Specify the hyperparameters and their possible values. Configure sampling. Choose a sampling method, random, grid or Bayesian. Early termination. Set up early stopping policies to terminate poorly performing runs. Run experiment. Submit the hyperdrive experiment to run multiple training jobs with different hyperparameter combinations. Analyze results. Review the results to identify the best hyperparameters for the model. Our next question is, explain the difference between machine learning and deep learning and how are these applied in Azure ML? Your answer should be machine learning ML, a subset of AI that uses algorithms to learn from the data and make predictions or decisions. Techniques include linear regression, decision trees, clustering, etc. Deep learning DL, a subset of ML that uses neural networks with many layers, deep neural networks, to model complex patterns in data. Techniques involves convolutional neural network CNNs for image data and recurrent neural networks RNNs for sequential data. Application in Azure ML. Azure ML provides tools for frameworks, example, scikit-learn, XGBoost to develop and deploy traditional ML models. DL. Azure ML supports deep learning frameworks like TensorFlow, PyTorch, and Keras, enabling the training and deployment of deep neural networks. Our next question is, how do you use Machine Learning Designer? Your answer should be, Azure ML Designer is a drag and drop interface for building ML models without writing code. Steps include workspace setup. Create or open an existing Azure ML workspace. Data ingestion. Drag and drop data sources into the canvas. Data preparation. Use data transformation models to clean and pre-process data. Model training. Select and configure ML algorithms, then connect them to your processed data. Model evaluation. Add evaluation models to access model performance. Pipeline creation. Chain together all steps to form a pipeline. Run and deploy. Execute the pipeline, visualize results, and deploy the models as a web service. If you find this content helpful, please like, comment, and subscribe to our channel. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested, and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you. Hello everyone. Welcome back to our channel. Today we are discussing interview question and answers for Microsoft Azure Data Scientist Associate DP-100. If you find this content helpful, please like, comment and subscribe to our channel. You can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Do share please. The question is, how do you handle model versioning and deployment in Azure ML? Your answer should be, model versioning and deployment in Azure ML involves the following step. Model registration. This is step 1. After training in model, register it to the Azure ML workspace to keep tracks of versions and metadata. Use model.register function in the Azure ML SDK to register models with the unique name and version number. Versioning. Each time the model is registered with the same name, Azure ML automatically assigns a new version number. Models can be retrieved by the name and version for reproducibility and comparison. Deployment. Choose the compute target for deployment such as Azure Kubernetes Service AKS for real-time scoring or Azure Container Instances ACI for development and testing. Create an inference configuration specifying the environment and scoring script. Deploy the model using the model.deploy function specifying the deployment configuration and compute target. Once deployed, the model is available at REST endpoint for real-time predictions. Monitoring. Use Azure Monitor and Application Insights to track performance and usage of deployed models. Set up alerts and dashboards to monitor metrics such as request rate, response times, and errors. Updating deployments. Update deployments by registering a new version of the model and redeploying it. Azure ML supports rolling updates to minimize downtime during the deployment changes. Our next question is, what is the role of Azure ML compute in model training and how it is managed? Your answer should be, Azure ML compute provides scalable and managed compute resources specifically designed for machine learning workloads. Key roles and management aspects include scalable computer. Provide scalable clusters that can be resized dynamically to match the training workload. Supports distributed training for large data sets and complex models. Managed infrastructure. Handle the underlying infrastructure including provisioning, scaling, and managing VMS. Offers different compute types CPU and GPU to optimize training performance and cost. Integration. Seamlessly integrates with Azure ML pipelines and experiments, allowing easy submission of training jobs. Supports popular ML frameworks such as TensorFlow, PyTorch, and scikit-learn. Configuration. Configure computer clusters using the Azure ML SDK or portal, specifying the VM size, max-min nodes, and idle shutdown policy. Use the AML compute class to define and manage compute targets programmatically. Resource management. Monitor compute usage and performance using Azure ML Studio or the SDK. Apply quotas and budget controls to manage cost effectively. If you find this content helpful, please like, comment and subscribe to our channel. If you are preparing for any Microsoft-based certification, you can download the complete list of valid, tried, tested and updated question and answers from the playlist link provided in the description. Wishing you all the very best. Thank you.